In this video, I'll demonstrate how to create a custom RIA protocol in MyAssays Desktop and publish that protocol to myassays2.com. By publishing my protocol online, I can share a link to the protocol with colleagues, allowing them to perform the custom analysis in their web browser without the need to have MyAssays Desktop installed on their own PC. For users working with MyAssays Desktop, the published protocol will be available for easy download and integration. I have an example measurement data file for my RIA, for which I'd like to create a custom analysis. Opening the data file, I'd like to import the data from column L, or the CPM data. One important note, this is a CSV data file created directly from my instrumentation. It's important that if we open the file in Excel that we don't save any changes, as this impacts the file format. If we need to save any changes to this file, instead, open it in an application such as Notepad. Now let's open the MyAssays Desktop Explorer and begin creating our custom protocol. I'll select New Protocol to launch the New Protocol wizard. I'll select the My Data is in a File or Spread Across Multiple Files option. Here I'll browse for and select my measurement data file. Leaving the Automatically Import Measurement Data checkbox selected, I'll press Next. On the next step, you'll see several different options for how to import data from my file. My measurement data file contains two columns of measurement data, Count and CPM. For my assay, I'm interested in CPM, so I'll select the Wizard 2 Dynamic CPM option and press Next. Here you can see our CPM data was successfully imported. On the next step, we can select which sample types are included in my assay. My assay has total tubes, NSB, standard, and unknown, so I'll make those selections and press Next. Here we can create our rack layout. Recall that one unique challenge of working with RIAs is that there can be a variable number of unknown samples included in each run. Typically, the tubes at the beginning of the run, the total, NSB, and standard tubes, will be static. However, depending on the number of samples in your run, the unknown sample type can be variable. MyAssays Desktop and MyAssays2.com allow you to specify sample types as dynamic, allowing for a variable number of samples to be included in each run. To begin specifying my layout, I'll select Create and select Clear to start with a blank slate. First, I have one total group, Run in Duplicate. I'll select Total from the Sample Type drop-down box, add one group with two replicates, so I'll update the replicates box to 2. I'll press Add Samples to add the samples to my layout. Next, I have one group of NSB tubes, also in duplicate, followed by 7 standard groups, again run in duplicate. Following my standard samples are my unknown samples, also run in duplicate. Once I've added my unknown sample type to the layout, you'll notice it's highlighted in yellow. This group has been automatically specified as a dynamic sample group, meaning that after the first 9 samples or 18 tubes, all additional measurements included in the analysis will be analyzed as unknown samples. We can preview the layout by pressing the Preview option, and if we're happy with our layout, we can press Save and Close. On the next step of the New Protocol wizard, we can see our measurement data with a rack layout overlay. And on the final step, we can specify a name for our protocol and optionally add a description. I'll add the name Custom RIA, and in the description, I'll provide a little more information on the analysis performed. First, we'll perform an NSB correction, then create a 4PL standard curve plotting concentration against corrected results, and last, we'll calculate the %CV. And on the last step, we can review the configuration summary and press Finish to launch the protocol. Once our protocol has launched, you can see a sample table containing our sample IDs, the tube numbers, and the imported CPM values. Let's start by adding a few analysis steps. I'll open the Properties control and select the Transforms tab. MyAssays Desktop uses the matrix transform analysis format, meaning that each step of the calculation is performed by a transform, which creates a new matrix of data available for further applicable calculations. I'll select Add to see a list of transforms that we can add. I'd like to perform essentially a blank correction, but instead of using a blank sample, I'll use the NSB sample. I'll select Blank Correction, and on the right-hand side of the screen, you can see additional information about the transform, including a description, properties, and examples. I'll press Create to add the transform to my protocol. Now I'll make a couple of adjustments to the settings. I do want to use blank group 1, but for the blank type, I'll select NSB. This will subtract the average of our NSB group, group 1, from all samples in our analysis. I also want to update the name of the output matrix. Since this is an NSB correction instead of a blank correction, I'll add the name NSB corrected. Next, we need to perform a standard curve fit. I'll select Add, Standard Curve Fit, and Create. With the standard curve fit transform added, we can see the input matrix defaults to the output matrix of the immediately preceding transform. I do want to use the NSB corrected data, but I wanted to point out that if I'd prefer to use the CPM raw data, I can use this drop-down box to make that adjustment. Now let's talk about the additional standard curve fit settings. We have axes settings right at the top. We're going to perform a 4PL fit, so semi-log axes are appropriate, with a logarithmic x and a linear y. Next, we can take a look at the calibrator concentrations. For this assay, I'll update the standard concentration values to begin at 200 and follow a series divided by 2. Scrolling down, we can optionally add a chart title, select how the calibrators are plotted, and add points to the curve and error bars if necessary. We can also add curve fit evaluations here. The fit settings allow us to specify a fit method, weight method, constraints, and data transforms. Opening the fit method drop-down box, you can see we have a lot of different options here, ranging from 4PL and 5PL to legacy fit methods. I'll leave the fit set to the default 4PL. I would like to add out-of-range labels. These labels will appear for samples with values outside the curve limits, meaning their y-axis values fall outside the asymptotes of the curve and return incalculable results. If we don't add labels here, the results will be reported as flagged. So I'll use the above drop-down box to apply the label greater than curve for samples above the limit, and opening the below drop-down box, I'll add the label less than curve for those appearing below the limits. I'd also like to display the average of our concentration results in the sample table, so I'll select Add and add the average transform. I'll rename the output matrix AVG concentration. All right, the last transform we need to add is the %CV transform. So I'll select Add, Percentage Coefficient of Variation, and press Create. Now I will need to update the input matrix to concentration instead of average concentration, because we'll need to use all the replicates of the sample group to calculate the %CV. Let's recalculate our results. On our report, you can see that our sample table has been expanded to include the NSB corrected, concentration, average concentration, and %CV. Following the sample table, we can see our curve chart, limits of quantification, curve fit equations, coefficient values, goodness measures, and our curve data table. All the information we need is available on our report, but I think we can improve the way it's presented. Looking back up at our sample table, I'd only like to display 2 decimal places for my concentration, average concentration, and %CV matrices. I'd also like to see my curve chart at the top of the report, and maybe we'll move some of the more granular curve fitting details to a different sheet. Again, opening the Properties control, this time I'll open the Matrices tab. The Matrices tab allows you to define how the data appears in the sample table. You can do things like update the numerical formatting, add sample labels, define which sample tables contain which data, and add value bars. I'll select the concentration, average concentration, and %CV matrices. You can select multiple matrices by holding Control and selecting additional matrices. I'll update the numerical formatting to 2 decimal places. Let's also add value bars to the average concentration and %CV matrices. I'll select average concentration and select the display value bars option. Next, I'll do the same for %CV, but this time I'll update the value bar colors to red. Now let's update the report ordering. I'll open the Report tab, and on the left-hand side, you can see the report tree, which contains all of my report elements in the order in which they'll appear on the report. I want my chart to appear first, so I'll move the standard curve fit element to the top of my report by selecting it and using these arrows. Here we can also add a sheet name to add content to separate sheets. I'd like the fit details to appear on a separate sheet named Fit Details, so I'll add that to the sheet name settings. Within the sample table settings, I'm going to report my standard results in the curve data table, so I'll open the Sample Types drop-down box and deselect Standard. I'd also like the sample table to appear on a sheet named Results, so I'll add that to the sheet name settings. One final change I'd like to make is on the XML tab. This will allow me to specify individual components of the curve fit report element, the chart and the curve data table, to appear on my results sheet instead of the fit details sheet. This is considered to be an advanced change, so if you need any help with this, don't hesitate to get in contact with us. Opening the XML tab, I'll scroll down to the standard curve fit report element, and beside the chart and the curve data table, I'll add a sheet name attribute and add results. I'll press Apply to apply the changes, and let's recalculate. Now on our report, you'll see some obvious changes. First, we have two sheets now, Results and Fit Details. On the Results sheet, we have our curve chart, followed by the curve data table, and then our sample table. The sample table numerical formatting has been updated for the concentration, average concentration, and %CV matrices, and our value bars also now appear on the report. Opening the Fit Details sheet, we can see more information about the fit itself, including the limits of quantification, curve fit equations, coefficient values, and goodness measures. If we open this report in Excel, the sheet-based format is maintained. I'm happy with this protocol, so let's go ahead and publish it to MyAssays2.com. To do this, I'll save my changes and close the protocol file and navigate to my MyAssays2.com homepage. Once I'm signed in, I'll select the My Protocols tab and select to Publish Protocol. I'll browse for and select my protocol file and press Next. I'd like to publish my assay to a new assay with public visibility, and press Next. Here we can edit the assay name and link. Perhaps for this assay, instead of Custom RIA, I'd like the name to be 4PL RIA. So I'll make that change and press Next. On the last step, we can press Publish to publish our assay. Once our assay is published, it appears in the My Protocols list, and we can select the folder icon to open the assay. Now we can perform analysis completely online, and you can share this URL with your colleagues to allow them to perform their own analyses without needing MyAssays Desktop installed on their PC. I have another data set which we can import by selecting the Choose File option, selecting our measurement data file, and pressing Open. And here you can see it was successfully imported, and this time we have a different number of unknowns. We can review the rack layout, edit the standard concentrations and sample IDs as needed, and pressing Calculate returns an interactive chart of our 4PL fit and our Excel-based report, showing the results separated onto two different sheets. If you or your colleagues have MyAssays Desktop installed on your PC, you can download this protocol for offline use by clicking the arrow to the right of the assay name and selecting to download MyAssays Desktop protocol. Once the download is complete, you can save it to your own PC and open to continue performing analysis offline. What if we'd like to have a nice, branded, page-based report? We can do that by editing the protocol in MyAssays Desktop and republishing it to MyAssays2.com. For a demonstration of this process, please see the next video in this series. If you have any questions about how to create a custom RIA protocol in MyAssays Desktop and publish it to myassays2.com, please email us at support@myassays.com.